Hello, welcome to Lesson 22, Scientific Notation. Today we are going to learn how to write numbers in standard notation and scientific notation. Before we begin, let's look at our key vocabulary word. Scientific notation, a way of writing very large or very small numbers. A number is written in scientific notation when a number between 1 and 10 is multiplied by a power of 10. So, what we're going to do today is we're going to practice going from scientific notation to standard notation, going from standard notation to scientific notation. So let's look at our next slide. How to write each number in standard notation. How to multiply by a power of 10. Move the decimal point to the right for a positive exponent and to the left for a negative exponent. So I have listed a few problems on the board, and we're going to practice doing that. If our exponent is positive, we move to the right. If it's negative, we move to the left. So let's look at the following. We have 5.8 times 10 to the 6th. That means I need to move my decimal point 6 places to the right. But look at what happens. When I move once, I'm out of numbers. That means I would have to add 5 zeros. 1 plus 5 is 6. So 1, 2, 3, 4, 5. I'm going to double check myself. Once, twice, 3 times, 4 times, 5 times, 6. So I moved my decimal point 6 times to the right. Then I need to clean it up. I come back 3 times and I add a 0. Come back 3 times, add a comma. So my final answer would be 5,800,000. 5.8 times 10 to the 6th would be 5,800,000. Okay, look at my next example. I have 1.34 being multiplied by 10 to the 4th power. My exponent is positive. That means I would move 4 times to the right. So I move once, twice. I'm out of numbers. So I've moved 2 times, but I need to move 4. I'm going to have to add 2 zeros. 2 plus 2 is 4. Check myself. 1, 2, 3, 4. Clean up that number, and it would simply be 13,400. 1.34 times 10 to the 4th power is 13,400. But look at our next two examples. Our next two examples have negative exponents. So the rule for that is to move to the left. 2.52. I need to move that decimal point 2 times to the left. I move it once, I'm out of numbers, so I'm going to have to add a 0. So my final answer would be 0.0252. My exponent was negative, I had to move to the left. And my last example, when I'm going from scientific to standard, I have a negative exponent of 3. That tells me I need to move 3 times to the left. So my original number is 3.056. I'm going to move once, I'm out of numbers, add 2 zeros, and that allows me to move 3 times, clean up my number, 0.003056. Again, this is going from scientific to standard. Scientific notation has a number between 1 and 10 being multiplied by a power of 10. If these numbers were not between 1 and 10, then they would really not be written in scientific notation. All right, so let's switch to this side. This time we have numbers that are in standard notation, and we need to move them to scientific. Let's look at a slide for that. Write each number in scientific notation. How do we do that? When putting numbers into scientific notation, if the number is less than 1, the exponent is negative. If the number is greater than 1, the exponent is positive. So, what we're going to do is we're going to look at these numbers. If they're smaller than 1, our exponent is negative. If the number is greater than 1, our exponent is positive. So this first number is very tiny. It's less than 1. We're going to have a negative exponent. What is the first whole number that you see? And let me rewrite that. My first whole number that I see is 3. So I'd simply say 3 or 3.0. times 10, and you have to count how many units you moved to get behind that 3. 1, 2, 3, 4, 5, 6. So my final answer would be 3 times 10 to the negative 6. Why is it a negative exponent? Because the original number was smaller than 1. Okay, let's try our next one, 13.045. Okay. Ask yourself, is this number larger than 1? Yes, it is, so I'm going to have a positive exponent. The first whole number that I see is 1, so I put my decimal point behind the 1. How many times did I have to come over to be behind that 1? Only one time. So times 10, or 10 to the first power. Check myself. Is this number between 1 and 10? Yes, it is. So anytime you're doing a problem like this, and if your number's not between 1 and 10, you need to back up and check yourself. Okay, let's look at the next example. 266.7009. Well, I will rewrite that so we can see it a little easier. My first whole number is 2, so I would put my decimal behind that 2. My exponent is going to be positive because this number is way larger than 1. How many times did I have to move to get behind the 2? 2 times. So my final answer would be 2.667009 times 10 to the second. Remember, all of these numbers drop down into your decimal. And let's keep moving. Our next example is a small number. Okay, it's less than 1, so we're going to have a negative exponent. So I'm going to rewrite it. My first whole number is 3, so I would put 3.04. Is that number between 1 and 10? Yes, it is. How many times did I have to move to get behind the 3? 2 times. My final answer would be 3.04 times 10 to the negative 2. Okay? Last one is 42. And sometimes this confuses my students because they don't see a decimal. I want you to realize that any whole number can be written as a decimal by putting a decimal point behind it at the end. Okay? My first whole number is a 4, so it would be 4.2. 4.2 is a number between 1 and 10. How many times did I have to move to get behind the 4? 1 time. Okay? So my final answer is 4.2 times 10 to the first, or just times 10. So we've covered how to go from scientific to standard, standard to scientific. I want to finish this lesson by doing 2 of your more complex problems that you may see. Okay? So 2 more to go and we'll wrap this lesson up. If you have 8.2 times 10 to the second power being multiplied by 3 times 10 to the fifth power. Now that looks really complicated, but I promise you it's not. What you're going to do is you're going to do a little bit of math. You're going to multiply 8.2 times 3 right off. 8.2 times 3, that's going to give you 24.6. In our previous lesson, we talked about our exponent rules. When you're multiplying powers with the same base, you keep the base and you add the exponent. So look at what I just did. I kept my 10 and I added 2 plus 5 to give me 7. Is this number in scientific notation? No, because 24.6 is not a number between 1 and 10. If I would say 2.46 times 10 to the first power, now it is almost there. Okay? I changed 24.6 to 2.46 times 10 to the first power, and I'll drop this down times 10 to the 7th. I'm going to clean it up by using my exponent rules. Okay? So my final answer would be 2.46 times 10 to the 8th. Where did the 8 come from? 1 plus 7 is 8. If you would have not have written in that imaginary 1, you would still be expected to know that 7 plus that imaginary 1 is 8. Okay, so that was our multiplication problem. Let's do a division, and then we'll wrap this lesson up. 3 times 10 to the 7th being divided by 8.1 times 10 to the 2nd. Okay, so I'm going to have to do a little bit of dividing. 3 divided by 8.1 is going to give us 0.37 when we round. What do you do whenever you are dividing powers with the same base? You keep the base, subtract the exponents. 7 minus 2 is 5. Check your number. Is it a number between 1 and 10? No, it's not. I would have to change it to 3.7 times 10 to the negative 1. Why is it negative? Because this number is less than 1. So we change this into scientific notation, drop down our times 10 to the 5th power, bring down 3.7, use our exponent rules to finish up with 10 to the 4th power. Negative 1 plus 5 is a positive 4. Again, those last two problems are a little bit trickier. You may want to rewind and watch them a few times before it makes sense to you. And that's all for scientific notation. I'll see you in the next lesson.